Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at using custom objects as values in a map. So objects of classes you defined yourself as the value in a map, and we'll take a look at the key, which is a bit more trickier, in the next tutorial. I've defined a class here called person, which has two instance variables, a name and an age, and I've also given it a handy constructor to initialize those values, and I've given it a print method that displays the information in it. We're going to look in a future tutorial at how to overload the put to operator, this operator here, so that we can use our own objects with cout, but for the moment we'll just give it this method called print, which I've also made that const. And in fact, let's get rid of this to start with, because I want to show you what happens if it's not const. I've created a map which contains ints as keys, and it contains my own objects of my own class as the values, and I've initialized this map with integer keys here. They don't have to be consecutive. I just happen to have made them consecutive here. I've initialized the values of those keys corresponding to those keys with my own objects here, each of which has a name and an age. Then I'm iterating through it, and I'm calling the print method on each of my objects here. So if I try to compile this, it doesn't work, and what actually happens is that it complains that I haven't got a default constructor, a constructor with no parameters. So when you define your own constructor that has parameters, you lose the default implementation of a constructor with no parameters, and the map needs that because it needs to construct the object, and then it needs to assign values to that object using the object that you set that equal to. So to fix that, we can put in here a person. We can put in a parameterless constructor, a constructor that has no parameters. And yeah, let's do that. I'm not quite sure how to pronounce that word, parameterless. Yeah, that's it. Okay. So let's use the constructor initialization list here to do the initialization. If we now try to build that, what I get is I'm still getting actually not an error, I think. Yeah, this is just telling me that name and age is not initialized. Oh yeah, because I made a stupid mistake here. We're not passing any parameters in. Okay, I need to give these default parameters. Okay, let's try this now and see if it builds. So I'll build this, and it's actually fine. So yeah, we didn't need that print to be const, but I think we're going to need that in the next tutorial. So we'll discuss that then. But basically, this is working. So if I run this now, we see that we're printing out we're using the print method in my person to display the name and the age of each person, and we're successfully displaying those values. We could display the key as well. So I could do cout it arrow first, and let's just put some punctuation in there and a flush. So if I run this now, we can see that the map sorts things in order of the keys, so it doesn't matter even if I put these keys in a completely different order of insert, and maybe I'll just change them to sort of different values as well while I'm at it. Map will always sort the objects in order of its keys. We've got 13250 there, and the insert of my custom object as the value is actually working. Now this is sufficient for most purposes, just providing a parameterless constructor. But you have to be aware that what's actually happening here is that the map is constructing the object using this constructor, and then it's assigning values to that object using the assignment operator, this equals sign here. And what that does by default is, by default, C++ gives your classes a default implementation of the assignment operator, which does what we call a shallow copy. That is, it just copies the values of your instance variables from the object that you're setting this one equal to. Sometimes you don't want that, because imagine you had a pointer as one of these instance variables, and you might allocate memory in your constructor, let's say. You don't want to copy, when you copy the object, you don't want to copy the value of of that pointer from the other object. You want to allocate more memory for that pointer. In general, you don't want to copy pointers when you do a copy of an object, because then you'll just get a pointer that's pointing at the same place that your other object's pointer is pointing to. So if you see what I mean, sometimes you don't want to do just a shallow copy where you're copying the values of all the variables. You want some of them to be different for the copied object. And in that case, you would need to override the assignment operator. And we're going to look at that in a future section on operator overriding. Now, you might want to provide a copy constructor as well. In this case, let's go ahead and try it. So let's create a person, and let's call this const person reference other, and we'll say name equals other.name, and age equals other.age. We still copy constructors in the free beginners tutorial that I created, or it might be the first section of this tutorial depending on where you're watching it. And let's also put in there a cout, copy constructor running, so we can see when it's actually running. And if I run this now, then it's not running. We don't see it running. But if I do an insert like this, let's say people dot insert make underscore per, and for the key let's make it 55 or something, and for the value person we'll say Bob and make him 45. So if we run this code now, we do find that the copy constructor runs. It's actually running 3 times, incredibly. Let's just try that again and see if it runs 6 times. So let's say Sue 24, and we run this. So 6 copy constructors, 3 times for every time we do this in one way or another. So you might want to provide a copy constructor. Again, there's a default copy constructor provided by C++, but that's only going to do a shallow copy, as with the assignment operator. So if you don't want to copy the values of some instance variables when you do the copy, or if you want to change them somehow in the copy, then you want to provide a copy constructor as well as overriding the assignment operator, which we'll look at later. But as I say, usually just the default implementations, implicit implementations of the copy constructor and assignment operator, usually they're okay for most purposes. Okay, so we'll leave it there for this tutorial, and we'll look at using custom objects as the keys in maps in the next tutorial. So until next time, happy coding.